Alright, welcome back to MECH2320, right? Motor controls. We're getting into chapter 3 here. We're going to start talking about manual starters, okay? So, for the most part, we should be able to discuss kind of, how a manual motor starts, what a low voltage release, and how to connect a manual motor starter. You guys are going to be doing this extensively in a lot of labs in class here, alright? Some direct wiring, some kind of, are kind of basic lab type wiring as well, but you will all be very hands-on in this class when we get to wiring up starters and things like that. Okay, so manual starter. This, means we're not using the PLC to start anything. We can literally walk over to the motor, press a button, and it starts to run. Kind of like on station 2 of the 870 trainer, right? I can walk over and I can hit the forward motor and the reverse motor, by hitting the manual start button on there. Now there are some other things built in so that we can control it with the PLC as well, okay? But the manual operation, you have to be at that position to start the motor. So like the conveyor that we have in the back of class, we have a manual start stop on there. I have to physically be there at that conveyor to start it and to stop it, okay? So it's the simplest starter. Okay, and when we talk about this, we talk about fractional horsepower single-phase motor starters. Okay. Now, when we talk about fractional horsepower motors, we're talking about motors that are generally 1 horsepower or less. Okay, so i.e. a fraction, like a 3/4 horsepower motor or half horsepower motor, those type of things. Okay, so that's what we're talking about. Small motors, all right, you're going to be working with some of these in class as well. Okay, so what do we really look at? It looks just kind of like a toggle switch, all right, and we'll look at some pictures here so you can kind of see that as well. Not always generally push button. We can toggle, and just flip a single pull switch, even one as simple as like the light switch you have in the house, kind of like we have on the manual. The manual, well, I guess it is manual, but on the mechanical trainer, alright, when we flip the switch, alright, so the motor turns on once everything's plugged up as well. Okay, so each one of these has an overload heater that's always connected in series with the motor. So what that's going to do is that overload heater is going to protect the motor. So the overload will open up. Now, why is it called a heater? Well, remember, when we send current through it, current produces heat. Okay, so if we size everything correctly, it's never going to get hot enough to open the circuit. But if something goes wrong and there's a short of some sort, it will get hot enough and open up the circuit, okay, and protect the motor. Okay, so that's when it trips. So all our motors, especially our high-end, 3-phase, we're all going to have some sort of overload protection on them. Okay, but they use heat in this instance. And it's the heat given off by the current that makes the circuit open up. Okay, so you can kind of see here in the upper left-hand corner where the heater connects in series with the motor. Why in series? Well, because remember, in series, current only has one path. So if it stops that path to the motor, all right, we're safe and secure. If it was in parallel, right, the current would just divert and go somewhere else and not protect it. So always in series. So we can kind of see in the bottom left hand corner, that's our schematic of our single pole manual starter. Single pole, right? We're going to do this in a couple labs where we just got a motor, right? This is like, simple as like your vacuum cleaner or things like that. Just a very simple motor running off 120 volts AC. Okay, so we have the contactor in there, and then we have the overload heater. So overload relay coil. So that's kind of a more familiar term that you'll see. You will see these on every single schematic for every single motor. Every motor we have to protect. Okay, so if we have starters that protect motors, if we have we're operating at 240 volts or things like that, we should have 2 load contactors, but we don't necessarily need 2 overload relays for this type of motor. And when we're talking about this motor, right, this might be like something like your dryer motor or something like that at your house. Remember, 2-phase doesn't exist, but we do need 2 lines in, all right, in order to get power and those sorts of things. So this would be our higher end voltage. Okay, so if we take a look, we're still looking at fractional horsepower starters here. I already mentioned it's the simplest motor starter. We're talking motors 1 horsepower less. Alright, so how do we wire those up? Those are wired up directly, what we call across the line starters. They're connected directly to the power. Okay, they don't go through anything else. And the contactors are manually opened and closed. That means you're physically there. You press the start button, it closes the contactors. You hit the stop button, it opens the contactors. The only problem with that, since it's manual start, okay, if power fails, so you're in the middle of producing something and the power fails, nobody hit the stop button, alright, the second the power is turned back on, that motor will automatically start back up. And that can present safety and things like that. So if you do have a motor like this that goes down or power fails, you need to make sure that you go over and find a way to shut off the power to this motor before working on it or bringing the other power. I know the power is already out, but you got to make sure that you either close the breaker, okay, or disconnect this motor so that when the true power comes back on, this motor won't kick in. Alright, it can damage whatever might be on a conveyor, or whatever the process it was doing. So just be very careful with that. Okay. If we mount these, okay, they're very, very simple to mount. You can see where we've mounted them on station 2 on the 870 trainer. Generally, you have a motor control center, so if you're controlling a bunch of motors at once, you have like a separate building that has a bunch of different enclosures all put together. It looks like a locker room essentially, and it's just bigger lockers and smaller lockers and things like that. They have all the starters in there, and everything's rated for the type of voltage and the type of horsepower motor and everything that's going out. So, but the starters themselves, okay, take very little space. You can see the manual starters. They can be inside those cabinets and things like that as well. And now, what I was talking about is a motor control center, so you will see starters in there as well. Those connect to the PLCs. I got on a little tangent. We are talking about manual motor starters. We do have to be at the equipment, so it will be generally maybe it looks like not a light switch button, but you'll see something similar to that, a box with your green and red button on it, start stop, or you're going to see maybe a panel that's sitting at that particular unit that you're working on, or machine that you're working with, and you have a start and stop button there. So it's manually located. So I misspoke a little bit ago about the motor control center. That's when we're running everything from one big spot, not our manual controller. So I just want to clarify that. Okay, very simple mounting, so we can see if we're putting on DIN rail or things like that, gang switch, conduit box, we can directly mount it to machinery as well. Alright, and we can come up with different kinds of enclosures, right? Remember, not every place is the same. It's a textile factory. We got to be explosion proof and dust and things like that, right? Because when we're switching on and off electricity, we create sparks. Alright, it's different if our environment might be wet. Okay, we might have to surface mount something. We might be working in a natural gas plant where there's vapors all over the place, or oil refinery. We don't want things to explode on us as we're working on it. So you might see these kind of different starters in different scenarios. Alright, so remember that when we talked about single switch starter, so we can see the difference between what an explosion proof enclosure looks like versus maybe a waterproof enclosure, right? There's going to be an extra gasket and seal and these kind of things to help keep things in and keep things from getting in and out of it as well. So we can see a dust-proof enclosure, right? That might be in like a textile factory or something. Waterproof enclosure might be something where we gotta start a motor and it's outside. Okay, so just different things, along those lines. We can also use pilot devices, all right, that also help. That the manual starter, we might still have to hit something, all right, it might already stay in a line, but we can also have like a thermostat. So if we have a certain temperature that's reached, all right, we have a blower that comes on to cool something like auto AC or those sort of things, right? Just kind of like in your house, you have the thermistor that sits there and you tell it, hey, I want my house at 68 degrees, and if it drops below that, the blower turns off, or if it goes above that, the blower turns on and your AC comes on and cools your house. So same kind of concept there. Still direct control kind of operation there, but we can still use that pilot to help, as a go-between. Okay, and when you do this, when we start talking about line voltages. In this case, it's 120 volts AC. So we just have a hot and neutral. So we have a single path for it. We want to make sure that all the contactors in there can handle the rated motor current. So it's very important. You go through the National Electric Code, okay, big thick book, and for, you know, it tells you what size starter that you should have for what size motor, and it'll tell you exactly what cable size that you need to run for all that. So you have to know the National Electric Code. Usually the engineering firm that's doing all the design ahead of time has to take care of all that for you. But if you're in maintenance and you got to repair and work on these things, you need to make sure that you're putting the right size cabling back on there, wiring on there, okay, and you buy the right size manual starter, because you can do a lot of damage. Because remember, current, you draw a lot of current, you can heat things up and you can destroy all that. You can melt wire, all that sort of things, okay. So when we're talking 120 volt AC, okay, the majority of everything we do, they're going to have contacts that are rated for 15 to 20 amperes. So this is just like the circuits in your house, right? If you go look at the panel in your house, the majority of everything is a 15 to 20 amp circuit, because that's what you're running on, right? When you plug in your vacuum cleaner or your blender or anything like that, main appliances that you plug in, all right, are rated for 15 to 20 amps. And you can only put a certain number of circuits that are on that as well. Okay, and then if we have our smaller pilot devices like this thermostat here that controls the blower, all right, you want to be able to rate that from 1 to 3 amps. I mean, generally, you have 120 volt AC, you're not going to draw, you know, you're not going to draw like 100 amps. All right, it's just not possible with that sort of thing, unless you got some crazy short going on. But most things, you know, we're going to be 1 to 3 amps because we're talking fractional horsepower motors. Okay, so we can also take a look at here. Here's a manual starter. Okay, this is 240 volts AC. So what do we got going on here? We can see where the contactors are. We can see where the overload heat relays are. And then we can see that, look, there's a manual switch, or we can toggle it into auto, so the pump will automatically come on if the float switch is closed, right? We're reading the level in a tank. So, you know, your house might have like a sump pump or something like that. So it detects, you know, after a lot of rain, it detects that there's water in there. And when the float switch reaches a certain, you know, depth, all right, the pump will start to pump and it'll kick the water out in your sump pump. So that way you don't have to come down there and manually start your sump pump. But you can manually start it or something along those as well, okay? So that's kind of the difference here between manual mode and auto mode. So you can see where there's a selector switch, and we can put it into manual so we can close the contactors and run the pump, or we can rely on a pilot device like the float switch here. When we have it in auto, the float switch handles everything. You know, just like your toilet has a float in there, right? And you flush it, all the water runs out, and as the tank behind your toilet fills back up, the float switch hits that certain point, closes, the water shuts off and doesn't fill the tank anymore. So same kind of concept there. And it's kind of funny, I mention the toilet and that a lot when we talk about a float switch, because I was in an engineering interview for doing antennas and RF signal, and one of the main questions the guy interviewing me asked me if I knew how a toilet worked. So it was very interesting that, you know, I did all my homework and tried to make sure I was talking about signal analysis and all these things, and he stuns me and shocks me because he's asking me, you know, how a toilet works, and I'm, you know, going to be calculating, you know, signals and things like that. So it was interesting, but just a little side note there. But okay, manual push button starters. All right, we have plenty of these around the classroom, so I'll make sure that I show these to you guys. You can see plenty of pictures here that I've posted here as well, so we can always check. Okay, so if we have higher voltages like we talked about before, okay, 240, we need to have at least 2 contactors. All right, we got to be able to handle the current. All right, 3-phase motors, we will always have 3 contacts on them. Right, we have to be able to have your A, B, and your C phase when you do that. So you'll see that those are bigger, and we'll take a look at those. I have some of those in class to pass around. You guys are going to be wiring up 240, and you're going to be wiring up 120. So don't be too scared, but do be cautious, and make sure you pay attention when we're doing everything. Okay, so you can take a look at the one on the left, right? That's a 3-phase line voltage manual starter. There, the contactors are going to be much bigger, and they're going to be able to handle the current. So when we do 3-phase, okay, notice that there is a overload heat protection on every single phase, and there's a contactor for every phase. Now, once again, the problem with one of these manual starters, if power fails, like power goes out in the plant, and you don't do something to stop this, when the main power comes back on, this motor is going to start up right where it left off. So always very dangerous here. So back to safety, lockout, tag out, making sure that before you bring the main power back up when it has gone down, is everything shut down and in the in the proper mode where it needs to be. Now we can protect these, okay? So we can have manual starters with a low voltage release. Okay, so in this case we can use a solenoid there. Okay, so we can make sure that by attaching the solenoid here, we'll release with a small amount of voltage, so that it will turn the motor off. Essentially, does that make sense? So if the power does go down, the solenoid will open up. It'll be a low voltage release. The contactors will open up. So remember, a solenoid is where we have a coil of wire, we're putting current through it, creates a magnetic field. So we can use that to protect these so that the contactors are automatically open when there's a loss of power to the main system. So with that solenoid in place, okay, as long as there's power going to that solenoid, it's creating that magnetic field and it's holding the contactors in place. The second the main power goes out, alright, that solenoid loses power and the spring releases. That's how the contacts release for safety. Okay? So, once again, we always got to talk about troubleshooting. We did a little bit again. Okay, so you don't want to trip or overload a motor. Alright, so how can that happen? Right? Motors, sometimes you short, or there's different things like that. So what can do all this? Well, you always want to check the motor and the circuit. Always check at your circuit first, because that's the easiest one to get to generally. Then you got to work your way to the motor if the motor goes bad. Sometimes the bearing goes bad. Sometimes you've shorted the winding somehow. Not necessarily you personally, but the motor might be old and things like that. Just excessive wear. There might have been excessive current. Alright, lightning around, there's surges, those different things. Someone could have been doing something in a panel down below and accidentally shorted something. Okay, excess heat. Alright, in rush, there's more current being. That's going to kind of go hand in hand with current, right? Excess current causes excess heat or overuse. Right, so something might bind that motor up, and it's going to try and draw more current to keep going. So just different things like that. Sometimes, loose connections cause issues, and then sometimes you overheat insulation and things like that that are on the motors that protect the windings and those sort of things. So, just food for thought. Make sure that, when you get into the real world and have to start, troubleshooting, so that you have some ideas in mind of what it could be if your motor's tripped or overloaded or things like that. Or why, the question is, why is a motor, continuously tripping? What on the system is causing that? So you've got to start to break it down and isolate it. Have a checklist for yourself so that you can go through and be like, oh, it's not this. I checked this. This is new. Did this happen 24 hours ago? Those sort of things. Is it something that we've already worked on that still isn't working right? So just different things like that. Another method, right, when the motor's running, we can always check the current. Alright, so we can use a clamp meter. Alright, that's the safest way to always check current, because if you use an ammeter or you use your multimeter, you have to, make that meter become part of the circuit. So the safest way, especially when you're talking 480 volt 3-phase and things like that, use a clamp meter. So you can go right in, clamp on it, okay? It's protected, it's not going to arc to anything, and you can take a reading, right? What is it really reading? It's reading the magnetic field given off by that current. But that's kind of really how the clamp meter is. So, check the motor current. Is it operating where it should be? Is it trying to draw more current, or is it not getting enough current? Different aspects of like those sort of things. You just got to think about it as you go through and check. All right, we'll do some labs on this stuff, so you guys will get some experience. But as usual, email me if you have any questions. Let me know if we need to team meet. All right, please make sure that you read the chapters in the book when you do the homework, because I don't cover absolutely everything in the lecture that is applied to the homework, because I expect you to read through and do the questions as well. So, all right, guys, have a great day. I'll see you in class.